This is Geometry A, Unit 5 on transformations. We're looking at Lesson 5, dilations. You may recall that a dilation means to grow or shrink. If you've ever been to the optometrist and had your eyes checked, they put drops in your eyes to dilate your pupils, right? That's to cause your pupils to change size, to grow. Dilation can be enlargement or reduction. It can be growing or shrinking, enlargement or reduction. And in mathematics, we do a dilation by multiplying by something called a scale factor. A scale factor. So, for example, I might take my x and y coordinates and I might multiply by 4. 4x, 4y. Okay? That would be an example of a dilation in which the size of the object changes by a factor of 4. Okay? Let's do an example. So here we go. Let's say we've got an xy coordinate. Okay, and let's put a shape on the screen here, right here. I'm going to put a triangle. It can be any shape. Like so. Okay. And actually, if I'm going to do a scale factor of 4, I better make the numbers a little smaller. Let's go there. All right. And I think I'm going to change the scale factor. Let's do just 3. Because I think even at this point, if I go with a scale factor of 4, I'm going to be off the grid. Okay, so I'm going to multiply by a scale factor of 3. Okay, so here we go. So here's A. And it seems to be -2, -1. Here's B, it seems to be 3, 1. And here's C, and it seems to be 4, -2. Okay, so let's do that here. So we have A, -2, comma, -1. We have B, 3, 1. And we have C, 4, -2. Okay, and we're going to multiply the x's by 3 and the y's by 3. So A prime, the image of A, is going to be 3 times 2, or -6, 3 times -1, or -3. B prime, the image of B, is going to be 3 times 3, or 9, 3 times 1, or 3. And C prime is going to be 3 times 4 is 12, 3 times 2 is 6, -6. Okay, so let's plot those points here. So A prime, -6, -3, 2, 4, 6, 2, 3. A prime, yep. Okay, and B prime is going to be 9, 3, 2, 4, 6, 8, 9, 2, 3. And C prime is going to be 12, -6, 2, 4, 6, 8, 10, 12, 2, 4, 6. Okay, C prime. And let's see what the result is. Okay, so here we go. And the object, you'll notice this line is parallel to AB. A prime, B prime is parallel. It has the same slope. A prime, C prime is parallel to AC. And B prime, C prime is parallel to BC as well. But notice now the triangle is the same shape, but it's now 3 times bigger. 3 times bigger. Okay? And that's because we multiplied all the numbers by 3. Okay? Let's do the same thing now. Let's do this transformation. Let's do xy becomes 1/2, or I'm going to divide, 1/2 x, 1/2 y. Okay? In that case, everything gets divided by 2. I'm going to do this fairly quickly. So a prime, I'm debating how to write this. So I'm just going to rewrite it. A -2, -1. A prime is going to be half of that. Half of 2 is 1. Half of -1 is -1/2. Okay. B is 3, 1. Half of that. B prime is 3 divided by 2, or 1.5. 1.5 or 1.5. And 1/2. C is 4, -2. C prime is 4 divided by 2, which is 2. -2 divided by 2, which is -1. So here we go. So A prime, then we'll call this double prime to distinguish it from the others. All right. So A double prime is -1, -1/2. There's A double prime. V double prime, 1.5, 1/2. 1.5, 1/2. And C double prime, 2, -1. 2, -1. Okay? And look at that. We've got, again, the same triangle, same shape, but we've got a very different size. The shape is half of that it was before. Okay, there we go. All right, and so that's a reduction. Reduction. And the green was an enlargement. Enlargement. And that's because the scale factor was different. So for an enlargement, the scale factor was 3. For a reduction, the scale factor was 1/2. So if the scale factor is greater than 1, we have an enlargement. It's getting bigger. If the scale factor is less than 1 but greater than 0, less than 1, we have a reduction. And this, I want to show you this in Desmos too, because it really is kind of cool the way it works. Let's pull up Desmos. Not DesLeast, but Desmos. All right. This is turning into a long video. Okay. So let's say I've got a triangle here. I'm going to enter my triangle by entering it as a table. So I'm going to enter -2, -1, 3, 1, 4, -2. Okay. And I'm going to tell it to draw. Come on. Draw lines. Boom. Okay, and to close it off, I need to go back to the original point. -2, -1. There we go. All right, and so now I'm going to enter a table again, but this table time I'm going to put a scale factor, so A. So -2A, -1A, I'm sounding Canadian, A, 3A, 1A, 4A, -2A, -2A, -1A. Okay, and we're going to enter a slider for A. So I'm going to say A equals 2. Okay, and there it is. Let's tell it to draw. Draw lines. Okay, and there's our triangle that is now 2 times bigger than it was. And I can make this triangle grow by making the scale factor bigger. I can make the triangle shrink by making the scale factor smaller. Now, one thing that happens when it gets negative, we end up with a point reflection across the origin. Really kind of fun there. You can play with that. All right. But when a is less than 1, when it's smaller than, like 0.6, when it's smaller than 1, a decimal smaller than 1, it's a reduction. Okay. One more thing that you need to be able to do, and I know I'm going long here, but this is something that they ask you about. If you have a triangle, let's say the side is 3, and it goes through a transformation, and now the side is 5. Okay, the scale factor is the new dimension divided by the old. That's very important to get. So the scale factor of this dilation is 5 to 3, or 5/3. We would say that's 1 2/3, or approximately 1.7. Okay, so the new dimension divided by the old. And this would be an example of an enlargement. We know from two things. One, the image is larger than the object. Okay, the new is larger than the old. The other is the scale factor is bigger than 1. Okay, so we know it's an enlargement.